Speech-emotion recognition on mobile devices has long been held back by a fundamental trade-off. High accuracy demands massive models, but those models can't run on phones. Today, we're diving into a breakthrough approach that shatters this bottleneck. DistilHuBERT, a distilled 8-bit quantized transformer that cuts model size by 92% while preserving 91% of full-scale performance. This isn't just another compression trick. It's a carefully engineered pipeline designed for real-world deployment, rigorous, generalizable, and built for edge devices. We'll walk through how a 23 MB model achieves 61.4% unweighted accuracy on IEMOCAP using a strict 5-fold leave one session out protocol, ensuring no speaker leakage, no overfitting to speaker traits, and a true test of generalization. But here's where it gets interesting. We didn't stop at one dataset. We augmented IEMOCAP with CREMA-D, 91 additional speakers, diverse recording conditions, and theatrical acted emotions. The result? A 1.2% boost in weighted accuracy, a 1.4% gain in macro F1 score, and a staggering 32% reduction in cross-fold variance. That's not just better performance, it's more stable, more reliable, more trustworthy. And the class-wise results tell a deeper story. Neutral emotion recognition improved by 4%, a major win. But sadness dropped by 2.9%. Why? Because CREMA-D's sadness is high-intensity, theatrical, and overexpressive, while IEMOCAP's is naturalistic, subtle, and low-energy. The model learned to recognize intensity, not nuance. So when it sees a quiet, introspective sadness, it mistakes it for neutral. This is what we call the theatricality gap, a critical insight for anyone building emotion systems. We tested this on raw VDSS, the gold standard for theatrical emotion data. The overall accuracy dropped to 46.64%. But the error pattern wasn't random. Predictions clustered by arousal level, not emotion category. Happiness bled into anger. Sadness bled into neutral. Why? Because actors prioritized clarity and vocal energy over subtlety. The model, trained on naturalistic prosody, couldn't distinguish valence in saturated, high-energy expressions. But here's the silver lining. The model still detected arousal robustly, 99% recall for anger, 55% for neutral, 27% for sadness. It didn't lose its mind. It just lost its ability to tell which emotion, but kept its grip on how strong the emotion is. That's not a failure, it's a feature. It means the model has learned physiological arousal as a generalizable signal. That's powerful, and it opens the door to a smarter deployment strategy. So how do we use this in practice? We propose a voice activity detection and temporal aggregation pipeline for long-form voice notes. First, remove silence and non-speech segments to eliminate neutral bias. Then, segment audio into 8-second windows, long enough to capture macroprosodic contours. Finally, average predictions across all windows. This pooling smooths out jitter, stabilizes sentiment, and surfaces the longitudinal emotional trend. This isn't just theory. We've built a full production model, trained on the entire IEMOCAP corpus with a 95-5 split, exported to ONNX for cross-platform efficiency. It hit 75.48% weighted accuracy, 76.4% unweighted accuracy, a massive leap from the cross-validation benchmark, while still fitting in under 23 MB. But the real win isn't just the numbers. It's the Pareto optimal balance between model size and accuracy. We're not sacrificing performance for efficiency. We're achieving near state-of-the-art accuracy with a footprint that fits on a phone. No cloud dependency. No privacy risk. No latency. And this work is fully reproducible. All code, training scripts, and models are on Kaggle. No black boxes, no gatekeeping. You can run it yourself. So what's next? Domain adaptation to bridge the theatricality gap. Fine-grained dimensional prediction, arousal and valence, leveraging the model's strength in arousal detection. And exploring neural architecture search to find even smaller, smarter models. In short, this is how you build effective computing for the real world. Not in labs with perfect data, but on phones with real users, in messy, natural speech. With rigor. With generalization. With purpose. Because the future of emotional AI isn't about bigger models. It's about smarter, leaner, more responsible ones. And this is just the beginning.